Okay, the third and final video about probability is going to be about compound events. And so if you remember in the previous videos, we talked about sample space with probability. We talked about simple events meaning there's one thing happening. So a compound event means there's more than one thing happening. Kind of like a compound sentence. There's more than one thought happening. A compound in science is made up of more than one thing. So, for example, a compound event could be rolling this dice once, twice. That's a compound event. I happen to land on 3 both times. But that's your compound. There's more than one event happening. I'm spinning a spinner and then I'm rolling a dice. I'm flipping a coin and then I'm rolling a dice. Those are compound events. Okay? Another really common compound event would be the example of when you draw out of a cup. Okay? So I could do one drawing. I might replace it. I do another. That's compound. I might draw a number out or a color out, not replace it or without replacement, and draw again. Those are compound events. Okay? So there's 2 types of compound events. You have independent compound events, meaning the first event has nothing to do with the second event. So I roll this dice, and then I roll it again. The fact that it landed on one first has nothing to do with what's going to happen in the second roll. Okay? So you have independent, and dependent compound events. And we talked about those. You have notes in your journals or in your notebooks about that. Those are not plural. Dependent, independent, and dependent. So independent is just that, like rolling a dice 2 times. They have nothing to do with each other. A common dependent example would be where you draw a color without replacement, go back and draw again. So if I wanted to get the blue game piece, that first drawing, the fact that I drew a red and didn't replace it affects the chances of drawing a blue. I now have a half chance or 50% chance of drawing blue. If I were to replace it or reset the experiment, that would be independent because my next event is not affected by the fact that I drew red first. Okay? So for dependent, a lot of times you'll see without replacement. You're going to see that phrase a lot. If it's dependent, that means the second event depends on what happens in the first event. Okay, kind of like science. You have independent variables and dependent. The dependent variable depends on what that choice is you make, that first thing that you make. Okay, so without replacement, what you'll see here, independent, a lot of times you'll see with replacement or replacement. Okay, so to kind of set it up a little bit, we're going to go back to the dice example because I think that's a pretty simple one. We'll just use the green one. Okay? So this is an example of a compound event. And I want you to decide if it's independent or dependent. So first thing you want to do when I roll a dice, what's all the things that can happen? I could land on a 1, a 2, a 3, a 4, a 5, or a 6. It's always a good idea to label out. That's why we said in class that we want to make sure that we draw a picture. I'm going to zoom in so y'all can see that. Okay? So let's say I want the probability of it landing on a 3. And then I roll it again, and I want to land on a 3 again. 3 is my lucky number, so that's what we're sticking with. Okay? So this is compound because there's more than one thing happening. So you should be thinking if it's independent or dependent right now. Rolling this dice twice. I'm not going to tell you. Okay? So probability of rolling a 3. You can look at your sample space or your picture. I want this right here. There's only one side out of these 6 that have a 3 on it. Then I'm going to roll it again. My chances of that are 1 out of 6. Okay? And we talked about this in class. When you multiply, or when you do probability, you multiply. There you go. So multiplying fractions, to find the probability of rolling a 3 and then rolling another 3, you just multiply these 2 probabilities together. And that's true every time with probability. If there's 2 events happening, you multiply the probability of each of those events. So 1 times 1 is 1. 6 times 6 is 36. And there's your answer. And the question might ask you to give your answer as a decimal or as a percent. For the purposes of this video, we're going to leave it as a fraction. You need to review how to convert it to a decimal or percent if that's what you feel like you need help with. Okay? But the probability is 1 out of 36. By the way, that was an independent event. Told you I wouldn't tell you, but I did. All right. Another example would be, let's say, picking these game pieces. So I'm going to start by drawing a picture. I'm going to say in that cup I have blue, red, and yellow. And I want to know the probability of picking a yellow, and then without replacing, let's say with the probability of drawing a red. So without replacement. So just like you did up here, if you want to pause the video and try this on your own, it is a good idea. But I'll go ahead and work it. So probability of yellow, there's 1 out of 3. I am not replacing that yellow. Goodbye. It's disappearing. So to kind of model that, how this would look, I went in here, I drew the yellow, I'm not replacing it. So in the cup are blue and red. I want the probability now of drawing red. Well, there's still 1 red in there, but there's only 2 total. Sometimes you'll hear like dependent, the denominator changes. As long as you draw it on your picture, you're going to remember there's 2 total now. There's 1 less. Same thing, as I said, when you calculate probability, compound probability, you're going to multiply straight across. Multiply those fractions. 1 times 1 is 1. 3 times 2 is 6. Ta-da! There's the probability of that happening. Okay? The only other vocabulary words we're kind of going to talk about in this video are experimental and theoretical. So we've done this, check, this, check. We need to do experimental and theoretical. So all of this is in theory. Okay? So think about when we go back to the dice example. In theory, there is a 1 out of 36 chance that I'm going to roll a 3 2 times. Will that actually happen? Well, we did that lab in class. And not this exact one, but if we actually did this experiment, and I did this 36 times, right? I rolled it twice, 36 times. The chances of one of those 36 times being both 3s, it's not going to happen every time. So whenever we're calculating this probability, guys, we're talking about in theory, okay? So what I want to care about is then comparing this in theory to experimental. And experimental is just what it sounds like. I got these fancy pens. We're going to color code this. There's the word experiment in it. And this you can almost see as the word theory. So theoretical means in theory what would happen. Experimental means what happened in that experiment. In science class, you do an experiment. You go around and you take data. You collect data. Okay? If you're measuring lung capacity, you're having to write down the data. If you are doing a mineral lab and you're making observations, you're writing down that data. So whenever you perform an experiment, you have to collect data. Now, in math, when we say determine the experimental probability, we have to give you the data. Okay? You're not actually going to go and do the lab on a test. It's going to say, hey, by the way, you did this experiment and this is what happened. Okay? So for example, we're going to look at this question. It's from one of your old homeworks. Zoom out so y'all can see it. Okay. It says a number cube, also known as a dice, with the numbers 1 through 6 is thrown 18 times. Out of those 18, it landed on the number 3 twice. What is the difference between experimental and theoretical probabilities? So there it is again. Experimental and theoretical. So I'm going to start with experimental, and I'm going to color code it. So all my experimental work is going to be done in this purple. Okay? So let me zoom in a little bit. Yeah, it's so small. Okay, good enough. Okay, so a number cube with the numbers 1 through 6 is thrown 18 times. Out of those 18, it landed on the number 3 twice. Okay? This right here is your experimental data. Number 3 twice. It tells you, hey, by the way, you rolled this cube 18 times. It landed on the number 3, 2 of those 18. That is an experiment. Experiment. That's your data or your data. Okay? So for experimental, I know that it landed on the number 3 twice. So it landed on the number 3, 2 out of 18 rolls. So 2 landed on 3, 18 total times that you rolled it. That's your experimental. Experimental. In theory, then, let's talk about it. It landed on 3. So I can even write it like this. I could have done that over here too. Probability of landing on 3. In theory, or theoretically, if I were to roll this dice, I expect it to land on 3, 1 out of 6 times. There's 6 total outcomes, and you're expected to land on one of those 6. Okay? So, you're almost there. This is your experimental. This is your theoretical. This question, this particular question, asks about the difference between the two. So when you see the word difference, you're thinking subtract. One of those keywords, and you got to be really careful with keywords, but when you want the difference between two things, a lot of times you can assume that it means you're going to have to subtract to find the difference between these two. Okay? So you could simplify this, but you know, so I could simplify this. This would be 1/9, but I'm going to leave it as 2/18. I'm going to work smarter, not harder here. I have 2/18 minus 1/6. If I'm subtracting fractions, I need a common denominator. So what could I multiply 6 by to get to 18? 3. So I'm going to write that as 3/18. Okay? And then you are going to notice an issue here if you haven't noticed it already. I don't want a negative number. I just want the difference between the two. So I could rewrite it as 3/18 minus 2/18. So let's go ahead and do that just to keep it clear. 3/18 minus 2/18. Because we don't want a negative number. We just want the difference between the two. So 3 minus 2 is 1. And we know that when we are doing adding and subtracting fractions, if they need a common denominator, we did all that work to find the common denominator, so we're going to keep it. I have 3/18 minus 2/18 gives me 1/18. So that is my answer on that one. Okay? So this kind of just walks you through all of it. Compound events, experimental, theoretical, all that kind of stuff. Just be very, very careful with it. This wraps up our probability videos, so stay tuned for more.